Good evening, everybody.
Good evening, sir.
Good evening, guys. Can we start? Uh,
Yes, we can start now, sir.
that's nice. So, good evening, all, and welcome to this live session of for the course on mathematical foundations of machine learning. I hope. Am I audible in the first place? It's all fine. I think they have already replied.
We are not visible, right?
No, I've not yet shared my screen. Yeah, yeah. Okay. So, uh, first of all, thanks a lot for taking this course, registering for this course, and I hope the course was useful to you. And can I? I mean, we can start with the questions, and towards the end, probably I'll do a conclusion. If there are any questions, we can actually start the questions now.
Hello.
Yes, Aman. I'll just share my screen. Just a minute. Can I be made the? Okay. Yeah, I'll just share the screen. Um, got it. I hope my screen is visible to all of you.
Yes, sir.
Yeah, go ahead, Aman.
Thank you, sir. Sir, I have one question.
Yes.
This is regarding the matrix derivative.
Uh-huh.
If it is x transpose ax,
Mm-hmm.
now if you take a derivative with respect to x,
Mm-hmm.
then sometimes it is mentioned as ax, sometimes it is mentioned as ax transpose. Now, so which
Oh,
one is the correct, right? So then there is a confusion in some, that whether it will be ax or ax transpose.
no, it's not the question of which one is correct. It is depending on what layout you are trying to do. You remember I had told you whether you are taking the numerator layout or the denominator layout.
Correct, sir.
Based on you fix up, you say that look, in the numerator layout, I'm just going to have all my what do you call working is going to be in numerator layout. Just leave it with that, and then you will get your solution. Is that clear? So the confusion will arise if we look at both. Take one, fix it up. I had to do that because it was just to tell you that there are two different ways of doing it. Okay.
Okay.
Yeah. Uh, sure. Okay. Are there? In fact, this question has a lot of participation. Yeah, please go ahead. I have. Oh man. Okay. What type of questions one can expect in the exam, or could you please elaborate on the exam pattern? Exam pattern will be exactly along the lines of how your assignment is. In the sense, exam patterns exam will also be MCQ types. What are the next steps from here towards latest technology in this field? What are the different roles to consider? Well, see, the whole idea about this course itself was to bridge the gap between the fundamentals and what you actually do it in what do you call in a machine learning domain, probably an advanced course or something. Because most of the times, what happens is like you start with advanced mathematics, thinking that okay, it's going to be a bit complicated. Many people that we have interviewed, we have probably even spoken about, they completely detest mathematics. They say machine learning is all about Python coding and so on. So this is the kind of inputs that we had got from many of the people that we've interacted, especially be it students or even at corporate houses when we talk to them. But you must also understand that an extensive amount of math is there. Maybe what do you call a follow-up course for this would be a good course on machine learning itself, where you would be able to appreciate all these ideas that we have given now with respect to those ideas of machine learning. For example, you might end up doing a full-fledged course on ML where they might teach you supervised learning, unsupervised learning, and all, where you will see all these mathematics there. I'm quite sure it's going to be of great help. And the other thing is also about you've asked like in terms of roles to consider. I mean, you could probably do research is one of the options that's always there. But I'm quite sure, see, in any probably place that you work, your value addition will come or most likely from the conceptual insights that you bring in to the table. I mean, if it's coding now, you almost see that there are many LLMs that you have which could actually do this coding business and other things. So the only suggestion is like you would probably strengthen your math and probably your analytical skills, which I'm going to which I'm confident will take you, through a longer distance than if you would probably, focus on coding and other things. So any company for that matter in AI and ML, your value addition is your conceptual grip that you have. So I think that's what I feel. Can you provide an example of how to compute the directional derivative and the gradient of a multivariate function? Okay, fine, let's do that. I will. I'll use my screen now. So what we'll do is we'll take a simple example and then see what is the directional derivative and other things. So maybe let's consider a simple example. Let's say we have a function f of, let's say, x1 comma x2. Let's say this is going to be x1 cube plus 2x1 squared x2 minus x2 cube. Let's take this. So the gradient we need to calculate. The gradient is nothing but, let's say, dou f by dou x1, the partial derivatives with respect to x1 and the partial derivative with respect to x2. Dou f by dou x1, dou f by dou x2. What is dou f by dou x1? I have it as 3x1 squared. Then there is 2x1 squared. So that is going to be, let's say, 4x1 x2. That's the directional derivative. That's the gradient with respect. That's the partial derivative with respect to x1, and partial derivative with respect to x2 is going to be 2x1 squared minus 3x2 squared, right? So now what you do is you put that in a column vector format or row vector format, depending on how you're going to do. So I'm going to take it as the dou f by dou x1. I'll take dou f by dou x2. So I'll put this in a column format. You're going to have 3x1 squared plus 4x1 x2. And then I'm going to have 2x1 squared minus 3x2 squared. Right? Now, what is interesting is I have this to be my gradient. So what I do is, let's say I'm standing on a hill and I'm basically standing at this particular point. So what I want to do is I want to evaluate the directional derivative of the function at this particular point in some specific direction. That is what we want, right? The directional derivative is basically along a specific direction, but then you're going to stand at a particular point and then look at, see, because it's a plane, you will have infinitely many directions. Now what you're going to do is we're going to stand at a particular point, and then so what you do is del f, let's say at 1 comma 1 in the and let's say, and the directional derivative in the direction of, let's say, directional derivative in the direction of, let's say, 1 minus 1. This is a valid direction. So what we'll do is you compute del f at 1 comma 1, which is going to be 3 plus 4, 7, and 2 minus 3, which is minus 1. So del f at 1 comma 1 will be del f of at 1 comma 1 is going to be 7 comma minus 1. Now directional derivative, take the dot product of this with 1 comma minus 1. So you get 7 plus 1, which is 8. That's all it is. So the directional derivative d is equal to del dot that 1 minus 1. So we are going to get 7 plus 1, which is 8. That is all it is. Okay. Okay, I have a few doubts to clarify. I've completed 6 assignments out of 12, getting good scores, and I also believe I do the same for the rest of the assignment. So my rest one assignment left. So by assumption, 7 assignments out of 12 assignments. This is somebody who had posted on YouTube also. I'm sorry, I was not able to respond to this. I think I will have to check with the NPTEL team as to what is the what would you call what is the uh, logistics for this. I really do not know. I will check with them and then I'll get back to you. I'm really sorry that I was not able to respond to you because I was also traveling. I couldn't do it. Okay. So it says-
Hello.
Yeah, please. Yeah.
Hello. Sir, I have two more questions. This is
Yeah.
Aman.
Uh-huh.
See,
One,
you,
1 minute, Aman, let me see if there are any other questions. I'll finish that and then come. Is that okay? Because there are people who have posted about assignments and other things, those clarifications I need to give, and then I'll get
Sure.
back to you. Is that okay? Yeah, that's great. Okay, so this is there. I just want to check whether the 8th assignment without submitting will be directly considered as 0 or any. I really have no clue. I have to check with the NPTEL team. You could probably write to the NPTEL team, also the backend team, and asking what is the how is it going to be considered? Okay. Okay. As we approach the end of the course, what should we do in future? Any book recommendations? I want to appear for GATE DA 2027 and go in quantitative finance field. Are there any research opportunities regarding ML in quant finance and IISc or any other institute? Well, if you want to do, I mean, a very good book is something which had come out very recently, titled The Maths for Machine Learning by Devadar Danka. In fact, I have quoted him in my lecture about when I did logistic regression, and I also follow his Twitter page. He seems to give some nice insights. You could probably look at that, and you could also look at all this Dyson Roth and other things. So if you want to appear for GATE 2027, I'm quite sure these books will be useful. Go in quantitative finance field. I'm not sure if anybody in IISc is working in quantitative finance, but I do know there are US universities which do offer MS programs in quantitative finance. So you could check up some of them. Why is the gradient in the direction of steepest descent, and what is the geometric intuition behind this? I think I have done this in the what do you call, in the course itself. See, if you look at let's say a three-dimensional what would you call a three-dimensional you're climbing a mountain or whatever it is, and you're at a particular height, and now you calculate the gradient. Now you would see there are two things that will happen when you calculate the gradient along the level curves. Along the level curve, nothing changes. There is no change at all. So therefore, the rate of change would be 0. Now, what is the maximum along the direction of level curve? The gradient being 0 says that okay, the slope is 0. Now you want to go high up. You want to go climb to the peak. So what you do? You look for the steepest direction. Steepest direction will be in the 90 degrees direction, right? 90 degrees line is going to be the steepest line, and when you see, you basically it points to the peak. So that is basically the steepest ascent direction. Is that clear? That's why what we do when you want to come down towards a minima, what you do is you go in the opposite direction of the gradient. You say it is basically the steepest descent direction. Okay. And I would also suggest, if in case you want to get more insights on this, I would suggest you to look at this book, How Machines Learn or Why Machines Learn by Anil Ananthaswamy, one of the best books. Please look at this. He has actually given a lot of insights on gradient descent. Okay. Sir, if possible, can you provide some book or resources for the upcoming examination for certification? Without much practice, it will be hard to get better marks. Whatever textbooks that I have given as reference in the course content, I think that would be sufficient. You can go through them. See, and most of the questions also, if you see, are what, I mean, you may not find many of them in the textbook. It is like on our own, we make certain questions and give. So if you know the concepts, I'm quite sure you'll be able to answer your exam. So please don't worry about this at all. Go through all the lectures that we have done. What would you call? That would be sufficient for you to face this exam. So please don't get stressed on this. Exam should be, I mean, of course, you paid for the exam, everything I understand, but exam, what I would suggest is like something which you don't worry. If your concept is clear, your exam will test only your concepts. Just don't worry. Okay. I want to say thanks to you because I got a good grasp of ML and linear algebra. Your previous course on linear algebra to geometry helped me the GATE exam. It also plays a significant role in my exam preparation. Thanks a lot. Thanks a lot, Vishal. Thank you. What does span of a set of vectors tell us about our data or features? Oh, very good. I will just put it in the linear algebraic term right now. Span, when you say it is the collection of all possible vectors that you can get, right? As a linear combination, you're basically going to look at the linear combination for all possible linear combinations of a given set of vectors. So it is just going to give you the different possible combinations that you can get. Is that clear? In our case, when you look at machine learning, a feature itself could be a linear combination of vectors. Okay, so it depends on what you're trying to look at. Can you outline the assumptions behind all common ML algorithms which influence the decision making or choosing appropriate algorithms? Okay, this is the assumptions behind all common ML algorithms. Okay, I can probably tell you a couple of them. I mean, if you say all behind all common ML algorithms, like I'm not sure if I can give you all that. But one thing you must understand, see, when you have, especially in ML, considering the fact that you have a lot of data, when there is a lot of data, there could be redundancy and there could be insufficiency. Both of them could be there, right? So when there is redundancy, you will always have issues. And when there is insufficiency, you will definitely not be able to make any decision. When there is, so what you do is you basically approximate. You want to look at the underlying structure of the data. What is the data trying to reveal? You're just going to find out that. So what you do is you only get some kind of an approximation. When you say you're looking at modeling a mathematical model or whatever it is, you're actually trying to do, that's why least squares, when you say you're not going to get ax equal to b at any point. If b is not in the column space of a, you're not going to get. So you're going to get least square solutions there. So what is the best approximate that I can get? The second thing is, even if you say I have large data is still insufficient data because you cannot really come to a conclusion and say this is what is going to happen. There's always going to be uncertainty there. That's exactly where we always say, okay, even with this much of data, even with this much of training and other things, our accuracy is still not 100%. You'd say it's like 95%, 99%, and so on. So there is amount of, so there, even if the basic idea is, even if you have large data, it could be insufficient data, therefore approximations have to be looked at, and the approximations must be such that you don't really pay a lot of penalty in your classification or prediction or whatever. Okay. Hi, Prakhar. From mechanical engineering. Okay. I left my steel plant job because of my interest in computer science. This course is terrific. I could have never learned calculus. Thanks a lot, Prakhar. Thanks a lot. I have to practice more. I would suggest there are a lot. If you want to practice problems, I would suggest you can look at almost all the universities, both in India and abroad, where they have put all their assignments on the web. You don't have to register for the exam. You solve those assignments. I'm sure you'll be mind blown by the kind of thought process that goes into, preparing those assignment questions. You will enjoy them, right? In Lagrange multiplier method, to find out optimum value of variables, if you get only single values of variables, which gives minimum. I didn't get your question at all. Look, to find out optimum value of the variable, if we get only single value of variables, which gives minimum of the function. How can we find the maximum of the function? See, it is basically optimized only, right? It's a question of you find out whether the function is going to have a minima or maxima, which will be coming out. You will see it with all your second derivative test, basically the Hessian and other things that will tell you. Then you can go ahead finding out the whatever minima, maxima, whatever that's there. How can we represent and transform data as geometric objects in higher dimensional space? This question, represent and transform data as geometric objects in higher dimensional space. See, the point is, beyond certain dimension, this geometry will not work. This geometry will create a problem, and the reason is you can't really visualize. You will. It's a question of lack of visualization tools or whatever it is. We don't even know beyond. Even in 3D, it becomes difficult many times. So what I would suggest is you learn things from 2D and 3D. Some back of the mind, you will be able to get the geometry of the data in higher dimension, which you don't really have to bother about what is happening at that dimension, right? When I say orthogonality, in whatever dimension the vectors are, you just know that the product of the vector must be 0, right? So this higher dimension, if you say geometry, yeah, you can say that this is the geometry, but beyond that, we will not be able to do anything. So you probably start working with your algebra at that time. How does Bayes' theorem formally describe the process of learning from the data? See, that's a good thing. See, it's all about conditional probability. When you say conditional probability P of A given B, you are trying to find out what you are trying to learn about the event A, given that event B has occurred. It's basically some kind of updation that you're trying to do. In Bayes' theorem, it's a different question that we're looking at. Say probably, I mean, I gave that example where you have multiple causes for what would you say, for a particular effect. You having known that this is the effect, you are trying to learn what is the chance that this could have been the cause. What is the chance of this could be this being the cause, right? So you already have certain learning. I mean, I'm quite sure most of you, when you visit doctors for certain kind of illness, you know that there is fever. Now the question is, retro, we try to find out what is the chance that it could be viral fever. See, the doctor would, the moment he sees you with fever, the doctor would actually say, look, oh, there is a possibility that it could be viral. I mean, later, if it is viral or not, depending on, your blood test and all things would come later. But then he learns from the symptoms that he gives. So your Bayes' theorem is something along those lines. Okay. Gradient descent or or how? Thank you for answering the question. Could you please elaborate how we can find gradient descent or any optimization where data keeps evolving, and one can say in time series of data? Oh, could be this could be a problem. Okay. What I'll do is, if you can post this question in the forum, I'll answer the forum, because that itself will take a lot of time for me to answer. Rupam, if you can post it in the forum, I'd be more than happy to answer there. Okay. I'll take up this question on forum because I I have another half an hour left and I have to respond to a lot of other questions because this involves evolving data and other things. So I would probably not answer here for the want of time. I will reply this on the forum, or probably I'll put it across for this live session. I'll put this across as a comment for the video. Is that okay? I have a few doubts to clarify. I have completed. Oh, this is already done. No? Yeah. The eighth one will be counted as 0. Then we will take the average, so that you got the answer. See, please do not post the same question again and again, because we will miss interesting questions, Query, sir. 1 minute. Oh, why is naive Bayes called the naive approach? Very good question. I hope I'm audible to all of you. Hello?
Yes, sir.
Yeah. What answer I would give if you ask me why is it called the naive approach? It's basically what do you call the way you do a normal, your naive Bayes theorem, and I mean, you would have studied the simple example of classification of spam emails versus the other email which contains certain keywords which would otherwise go to spam, right? So it's a very what would I call very it's I don't even know how to put that properly. Maybe I'll before the end of the session I'll try to answer. Okay, it's a good one. I'll just check. Why should I?
Sir,
Yeah.
can we tell that as, in naive base, we are assuming independence of features on the output? Like we are not focusing
yes.
on
That,
like,
definitely.
yeah.
That is one. No, when you say it is naive, so I was thinking, okay, is that the literal meaning that you're trying to ask, for which I need to answer? So I was like more into that. Okay, not otherwise. So anyway, I'll try to give you an answer for that. You're correct. Independence of features is one reason. Okay. The correlation versus causation. Why are these not related? Why are these not related? What do you mean by why are these not related? Ravi, could you?
Sir, correlation does not mean causation like that it is written.
Oh, that is correct. No.
How, say A and B are variables, and you draw a graph, and A increases, say B increases,
Uh-huh.
or A decreases, B decreases,
Uh,
or there is no correlation.
there is a fantastic example. There is you can check it on the web also. There's a data which says like they plotted what do you call the number of students graduating out of Indian universities against the number of divorce cases that happened in Australia. Now it says that as the number of engineering graduates increase, the divorce cases in Australia also increases. So can we say that that's exactly what it is, right?
Okay.
So correlation can never be.
Okay. Thank you, sir, for giving very illuminating example.
if we end up
This is
doing that,
typical of your lectures. Actually,
oh,
thank you very much for all these insights you are providing.
thank you. Thanks a lot. Thanks a lot. Thank you. There are many clustering algorithms, and I'm unable to understand how to use the best one and how to mark decision in this aspect. See, this is typically out of experience you'll get. It's not that you say, okay, you use this algorithm and you get it done and go. It is not going to happen. It comes out of experience. So typically that's exactly what we were saying. So what are you trying to look at? When you say your algorithm, you want to do this, there are so many other workhorse algorithms and all. Like the question is like, what are you trying to look at? You want to minimize the squared error, you want to minimize something else, you want to do this, you want to do that, you want to, like PCA, you want to look at the direction of maximum variance. You really have to find out what you are trying to look at. And based on that, you have to choose the algorithm. There is no simple algorithm which will say, or a strategy which would say, you pull this algorithm and you put it, you get it. I've seen in multiple places, where you, with naked eye, you see that there is absolutely no linear relationship between the two variables, and still people say, look, I will put a linear regression and then it's going to work. No, it will not work. So these are things which will come out of experience and then a lot of practice. So I would suggest you guys start looking at data and then see like what is happening, right? I could not understand the difference between cumulative distribution function and probability density function. See, I think I gave you this example for, you forget about probability density function for a while. I will just talk about probability mass function. When we talk about probability mass function, it says, look, if I have a random variable which can take, say, 10 different values, I want to find out how this probability mass of 1 is distributed to these 10 guys. Every guy has a fraction of that unit mass associated with each of those values. So you call that to be the probability mass. This is like how you're going to, the example that I gave you. What is that? You have your bank account. Every month you may deposit some amount to your account. Exact amount, this is the amount that I have deposited in my bank account for this month of, let's say, September, for this month of October, and so on. That corresponds to your probability mass function. When I don't have this, suppose I do not know how much I have deposited. The bank is also not willing to tell me, look, you don't keep asking me for getting the details of your passbook or whatever it is. I cannot give you. You check it online. I will only tell you how much money you have deposited till now. You basically accumulated it. You say, instead of saying January, February, March, April, May, June, what I do is I tell you from January till September, this is the amount that is there in your account. Now, with this information, and somebody tells you from April to September, you've deposited this amount. Now, I'll be able to figure out what is the total amount that I've deposited between April and September. So, your cumulative distribution function basically does that. It does not give you the exact value of probability mass at every point. Instead, what you say is P of X less than or equal to A. What is the probability mass that I've accumulated till this point A? Similarly, if you look at density function, you are going to look at probability of X less than or equal to A. That means you want to find out what is the area under the curve till A. You're getting it? If you look at the curve that I've shown there, where there's this arrow mark, you say, suppose you call this as, let's say, you call this as the point A and it goes like this. I call this as point A. And let's say the function also goes like this. What I'll do is I'll take from minus infinity to A. What is the area under this curve? So this is going to give me my cumulative distribution function till A. Is that clear? So cumulative distribution function is like saying, what is the amount of money that I've deposited till a particular point? Whereas probability mass function will say, what is the amount of money that I have put every month? Density function, we already saw what is the idea behind density function. Your probability mass is 0 of the individual point. So what I do is I look for the, instead of saying I want to look at probability of a particular value for a continuous random variable, I will say what is the probability of finding the random variable between these 2 points in an interval. The example that I can give you is like, you might all go for, a movie with your, you might have planned for a movie with your friends, say all of us will meet at 4 o'clock. And exactly 4 o'clock, all of you meeting, it would be a very low probability event, which I was saying, look, what is the probability of meeting your friends between 3:45 and 4:15 within a half an hour interval? This has a slightly better probability than our probability of meeting at exactly 4. So what we say is, whenever you have continuous random variable, we don't talk about probability mass. Instead, what we say is, we want to find out the probability of finding the random variable within an interval delta X. That is what your density function is, okay? I hope that, Prakhar, that gave some kind of clarification. Prakhar, are you there?
Yes, I am here, and sir, I got clarified.
You got that clarified?
Thank you, sir.
Thanks a lot,
Yes.
Prakhar. Thank you. How to keep on studying things without losing motivation? Yeah, just a minute.
Sir, excuse me, sir. Yeah, okay.
Yeah, go ahead.
So sorry for disturbing.
No issues.
Sir.
Aman, you are still waiting with your question. I'll answer your question. Okay.
Yeah, sure, sir.
Yeah, go ahead. Whoever had asked.
Sir, I don't know is this correct platform for asking this question or not. I have this one query about related to research. I just want to know, is there any research topics that are related to mathematics and both machine learning and data science?
Oh, there are lots of them. I mean, you need to figure out. Don't worry about. See, that's.
Can you give me some examples so that?
I mean, now everybody talks about all your LLMs and other things, which is going to be, which is mathematically dominant actually.
Okay.
Now people have come to know, we'll use small language models. I was actually seeing some articles on small language models that would again use some math, right?
Okay.
So
yes, sir.
But one thing you must understand. I don't know if I am actually giving you a proper analogy, but to me, this actually makes a lot of sense. Whenever you talk about math and machine learning,
not only machine learning, sir, AI and all.
Whatever it is, this entire,
yeah.
The modern jazzy terms that you have, AI, machine learning,
yes, data science and all.
Data science,
yes,
deep learning, whatever you want to put that, okay?
Yeah.
See, this modern machine learning that you have is like our Krishna avatar.
Okay.
When Yashoda was trying to tie Krishna with a rope.
Okay.
When she was trying to tie Krishna with the rope, then the rope, suddenly Krishna will, the size of Krishna will go up. So she will fall short of some rope.
Okay.
Then she'll
Okay.
go get another one bigger rope. Then again, Krishna will grow up a bit more. She will again fall short. You're getting it?
Yes, sir. Getting it.
So
Yeah.
if I were to equate it, the modern machine learning that you have is exactly like Krishna. Whatever math that you want to tie it with or learn that math, that ML with that mathematics, you go
Okay.
there, you'll feel, oh, this is insufficient. Okay, let's take. See, initially when people are talking about all these things, the only major
Is there any emerging research areas that that
it might come.
beginners can work?
It might come definitely because I mean, finally you have to make sense to your data. I'm quite sure
Mhm.
it might come. It is already in the process. So what happens is like when people are talking about only linear algebra, probability, statistics, and then let's say
Yeah.
optimization as far as the math is concerned, then
Okay.
now you see the tentacles that machine learning has spread in terms of mathematics. People learn topology also. People learn
Yeah.
real also.
Yes,
Right?
sir. Yes,
People learn
sir. I
differential.
am from mathematics department only.
Yeah, so people learn every possible math. So this octopus is actually taking in everything, and it is still not sufficient for us to clearly, say that this is okay. That's the end of the math that you need. You're getting it.
Yes, sir. Yes,
So
sir.
it
Yeah.
keeps growing, and that's the best part about this machine learning. You find it very, very interesting that it throws up new challenges, and then you start looking into okay, people who are hating mathematics now. For a long time, they come back to it now. And I know many of these. I mean, you see, many of these medical practitioners would have actually wanted to take, let's say, biology in their class, while saying, "Okay, this math is tough, but I want to become a doctor." When they go for doing this, what do you call medicine? They might not have done any math at all because their course itself is like quite demanding for them. Now, with the advent of this, what do you call this, the dominance of this ML and AI that has come, most of these medical practitioners are actually turning to courses where there are math.
Okay,
Right?
sir. Okay. Yeah. Yeah. Yeah.
The best part is they have domain knowledge and they also have the data, which means they'll say, I will work on it. I will learn the math and I'll make sense out of myself. Why would I want to pay somebody else? You're getting it?
Yeah. Yes,
Yeah.
sir. So, and one more thing, sir, like assignment solutions are not uploaded in that link. Can you please look at it too?
I will
Look at
just
it.
check it up. I'll check it up. I've not been seeing the forum for some time because I'd been in the middle of some really stupid travels. I will do
Okay,
that.
sir. No
Okay.
problem, sir. Okay. Please
Yeah,
look
thanks.
at it, sir. Thank you, sir. Thank you so much.
Sure. How to keep on studying things without losing motivation? Because I followed religiously for some weeks, then I couldn't study further. Do you have any suggestions? So what should I say? Kiran, do you think the course was not motivating you to, go forward beyond whatever weeks that you have done? I really do not know. Yeah. But if you want to really keep up your motives, yeah, Kiran.
Sir, actually, like I followed like till the third week. Then like I every lecture I watched it twice to understand. They took the notes, and then like when the things were getting difficult to understand, then I thought like I don't know what happened, but I stopped and like look
So
at
you could have
yeah.
sent us a message, me or all the TAs who are there or in the forum. We would have definitely helped you out. See,
Okay.
it's not, see, keeping motivation is also there on your own. See, what happens is like when you start looking at math only in terms of formulae and other things, and trying to mug up derivations and all, you'll feel it boring. You lose your motivation. That's why always I would suggest that you look at blogs and Quora and Medium articles where you get some really interesting insight.
Okay.
Very interesting insights that you get, and it's not necessary that you really have to read only all these standard textbooks that are there for prescribed for these topics. You also have really off-key books. For example, the one by Anil Anthaswamy, like Why Machines Learn or How Machines Learn. That book, cover to cover, you can sit and read. You will be wondering, look, how did I miss reading this book? This gives me so much that, which will help me now understand. Go back to any standard textbook, I'll be able to understand. That's the kind of thing you must be looking at. Okay.
Okay.
So don't worry about this losing motivation. It's always nice to lose motivation in between and then, come back with a result saying, look, I will do it. Come what may, I've registered for this course. I'll do it. So you will have to complete it, right? There's no going back. If you've taken up something, you have to go forward, right?
Yeah. So that's what
Okay,
like the main thing happens is that really like when we study for like a week and then like continuously and then we feel like the natural force doesn't come within.
There is one more reason probably I would say. I do not know what the audience felt, but I would definitely say, see, every lecture in a week is going to be 30 minutes, but I have never
Yes.
been able to complete it 30 minutes. Somebody sees 45 minutes and says, this guy is talking
Yes.
5 minutes. We don't know what to do. I got it, Kiran, where you're coming to, right? See, the point is, the reason why we have overshot in almost all my lectures, at least I have done, is because I wouldn't come prepared with some lecture notes to teach. I'll come there and then I will decide a flow. Okay, today these are topics that I go, and when I teach, I will get some questions on, as I teach. Okay, this could be a question that the participants might ask. Then I'll be addressing that. So this is one thing which was the cost for. Okay, somebody asked correlation and causation. This is the causation, and the correlation you can see in terms of the longer lecture hours. So that's precisely why we don't want to stop it right there saying, okay, it is over, so I'll stop. We wanted to go to that walk that extra mile so that the concept is conveyed to you properly. Is that clear? Maybe you can watch it as 1.5x or something. You'll be able to see it better. Okay.
Yeah.
Thank
Yeah,
you. Yeah.
Thank you, sir. Thank you.
This isn't a question. I'm happy to be a part of this course, and I'm taking the liberty to suggest you all a resource apart from our wonderful course here, which would be very helpful. 3 blue, 1 brown. Our visualizations were all using the Manim tool of 3 blue, 1 brown only, right? In fact, there is another interesting digital book that's available, which is titled Interactive Linear Algebra. So you'll see a lot of interesting things. In fact, even the linear algebra through geometry course, which we are doing this time, is along the lines of 3 blue, 1 brown. But our TAs did some amazing job in getting the visualizations done. Thanks a lot for that suggestion to everybody, Hariharan. Thanks a lot. Can you help me understand the use of Hessian and its application to ML? I was finding it difficult to understand its use. Okay. You see, when you do a simple y is equal to f of x, you want to find the maxima or minima. What is the condition for a maxima or minima when you have y is equal to f of x? You take the first derivative, equate it to 0, then take the second derivative. At that point that you got dy by dx is equal to 0, that x value, you substitute that in the second derivative and then check whether the second derivative is going to be positive, negative, or whatever, and then you decide. Right? That's what you decide whether, if the second derivative is positive, then you say you have hit a minima. If the second derivative is negative, you say you've hit a maxima. When you have multiple functions of multiple variables, it is really difficult to do it this way, because you will have derivatives along each and every direction. The rate of change can be along each of the directions. Therefore, what you do is you got into the idea of gradient. And now what we want to do is we want to look at something similar to the second derivative test, which we had d square y by dx squared. Looking at the sign of that, we want to check that. That is possible here with the Hessian matrix. What you do is you calculate the second derivative of the gradient that you have. So you will have cross products and other things. So you put that in a matrix form. Now, how do I know that I'm going to get a maxima or minima? So you just need to find out if the second derivative of if the Hessian matrix that you have is a positive definite, then or a negative definite, based on which you can decide whether it's going to have a maxima or minima. You also have conditions for the Hessian. So this is all it is. Take the derivative of the derivative. That's it. Okay.
Sir, in this aspect, when you are
Yes.
finding the positive definite and this thing for Hessian, we look at the eigenvalues, right?
Yes.
So how does the concept of eigenvalues come with this Hessian to help us?
That's a fantastic question. I will convey this through another idea. Can I do it?
Okay.
Look at this. I think I have done this as a part of covariance matrix when I did variance of x1 plus x2. When we took it as variance of x1 plus variance of x2 plus 2 times covariance of x1, x2. We did that, right? And then we express this variance of x1 plus x2 in terms of matrix. We took that as 1, 1 transpose into the covariance matrix into 1, 1 vector we took. right? See, we know that the variance is always going to be negative, I mean, 0 or positive. Is that right? It's a non-negative number. Is that correct? If
Yeah.
all the data points are the same, then the variance is 0. Otherwise, variance is going to be positive because it is your sum of squares comes into picture. Is that correct?
Correct.
So now, if I want to, and that's exactly where we got into that eigenvalues, because you look at this, what do you call, x transpose ax, right? If you take x transpose ax, you would say ax equal to lambda x. Is that correct?
Yeah,
Eigenvalues
correct.
in terms of eigenvalues, eigenvectors. Now, what you do is you are looking at lambda times x transpose x. This lambda you move it before because it's a scalar.
Yeah, you get x square.
X transpose x is sum of squares, which means it will be positive or 0. Is that correct? What is the
Exactly.
factor which is going to decide whether it is positive or negative? Lambda value is going to decide.
Sir, are you writing on the board?
No, I'm not writing. I'm just giving oral this one. I don't want to write anything on the board right now because if I start writing, we will miss time.
Okay, okay.
Are you getting it?
Yeah, you said ax equal to lambda x. After that?
Ax equal to lambda x you have, right? Eigenvalues.
Yes.
So instead of ax, I will write this as x transpose lambda x. Can I do it?
Yes.
Lambda, I can move it before x transpose because lambda is a scalar. So I'll get x transpose x. Is that correct? X transpose x is sum of squares. X1 square plus x2 square plus x3 square plus xn square. Sum of squares which will either be 0 or positive. Is that right?
Yeah.
What is going to decide whether the entire thing is going to be positive or negative is based on lambda. Is that correct?
Yeah. Yeah.
That's all it is. You already see what's happening. If lambda is negative, you say it's negative definite. You say lambda is positive, you say it's positive definite, right?
Yeah.
That's why there's one more question where we had a lot of interesting discussion in the forum where they said, look, the determinant is greater than 0 is a property of covariance matrix. Determinant greater than 0 is a property of covariance matrix coming from the fact that the lambda is either greater than or equal to 0. If the lambda is I can have two lambda values which are negative, and multiplication of these two eigenvalues will give me a determinant which is positive, right? If it's a 2 by 2 matrix.
Yes, yes.
So that doesn't work. So it's a consequence of you saying, I cannot decide anything from the determinant. If I say determinant is non-negative, it is not going to tell me whether the eigenvalues are non-negative. You're getting it?
I get it, but intuitively, if I'm trying to understand,
So intuitively, I've given you the entire expression now. C transpose, X transpose AX, you become X transpose lambda X. That's it. After that, you look at it. You get the answer. Okay.
Yeah. Also, one more doubt. You suggested the book by Anil Ananthaswamy, right? So it covers all these mathematical topics like linear algebra, probability, and all that in an intuitive way.
He does everything. He does it for somebody who's not mathematics savvy.
Okay.
But he does show all the equations and things. So I would suggest you to read that book. Fantastic book it is. Okay.
Sure. Thank you, sir.
Great. Okay. Can we say machine learning models are type of dynamical system? No, what do you mean by dynamical system? Can somebody throw light on this? Like if somebody can tell me what is it that they want to, Anshuman Bose. Oh no, who's that? Yeah, Aditya Banerjee.
So, like, as I can see, like, there is some, when we are working with some of these models, like, there's some convergence, there's some stability, and this type of phenomenon. So, from that notion, like, can we just say they're like some simple form of dynamical systems that we use for prediction?
Dynamical systems will also, I mean, you may say a class of dynamic systems, but on the whole, you cannot put all of them together, I guess. Okay.
Okay.
Yeah. Can anyone send me the link to the forum or assignments discussion? Anshuman, this is there through the NPTEL site itself. You have to register, but I think, I don't know if you can register now. Okay, please check that out. Now I'll answer Aman's question. Aman had been waiting for quite some time and then I'll take up. Aman, can you go ahead, Aman? Before I take the questions from Prakar, can Aman tell me what's your question, Aman?
Yeah. So, sir, I have one question. This is regarding the statement which is mentioned over there while in the lecture. that inside some disk of positive radius centered at x0, y0, there is some sufficiently small r is greater than 0. So I'm not able to understand this. What do you mean by inside some disk of positive radius centered at xy? It is
This is radius
it
is
is
positive. Yeah, go ahead.
local. It is basically when a function is said to have a local maxima at x0,
Yes,
y0.
yes.
Yeah.
It is with respect to that.
Yeah.
Yeah.
So could you please explain that statement?
Okay, I'll do one thing, Aman. Probably I'll post this also in the group. Okay, for want of time. Okay, I'll post this. I'll post this reply in the group. Is that okay? You're a part of the forum.
Yes, please.
So I'll post that in the forum. Maybe this weekend I'll sit out and then I'll post all these things. Is that okay?
Yeah.
Yeah.
And my second question is, suppose we are doing a matrix derivative of x transpose x, then it will be a 2x transpose. But if we are doing a outer product or matrix derivative or the derivative of the outer product, let's say x transpose. Right. In that case, it will be a complete matrix which will not be determined. Right. This is my understanding correct?
It's a completely different. See, if you take XX transpose, you'll actually get a matrix. Now you want to look at derivative of this XX transpose. It's a matrix which will again go back to derivative of your the matrix A or whatever. Are you getting it?
Yeah. It's matrix only. Yeah.
Yes.
Okay.
So I'll answer this question, and there's one more which people had posted before. Aditya, I would request you to copy that question and then keep it, right? There's one question where was this question? There's one question which I said I will do it. I'll send the answer in the forum. Aditya, do you remember this question?
The gradient one, right?
Why is the gradient in the direction of steep and descent? I think I answered geometric intuition, right? One more thing was there. You forgot. Let me just check. Just give me a minute. I think it's about the Lagrangian multiplier, or just give me a minute. I'll check this. This question: how do we find gradient descent of or any optimization when data keeps evolving, or one can say in time series data? That's a question. It's from Rupam. Can you just note out that question? Check that question, and this one what Aman just posted. Okay, take these two. Okay, how is expectation different from probability? What do you mean by that? You mentioned that expectation is the best predictor outcome of an experiment. So if I know the probability of an event, will calculating the expectation give me a clear picture of the outcome of a random experiment? See, it's not that. I'll give you what do you call a simple example. Suppose I ask, I think you have a sufficiently good amount of participants in this group right now. In the current meeting, I think we have at least some 20, 30 people. Suppose I ask you, can you tell me what is the salary that each of you join? I mean, drop. First thing you will do is you will drop off from the call. Why is this fellow asking me the salary that I drop? But I tell you, look, in the absence of you giving me any information, suppose I tell you the average salary drawn here is basically, let's say, some 30 lakhs per annum. I don't have the data, but this 30 lakhs per annum seems to be a reasonable assumption, right? I'll give you another example. All of you, when you present your academic credentials, what do you present in your biodata? You present your CGPA, right? You present your average. Is that correct? Are you getting it, Prakhar? Hello, Prakhar. Are you there? You are
Yes, sir, I'm here.
Yeah, you're basically giving your average. Is that correct?
Yes, sir.
You don't give me the semester-wise marks or your subject-wise marks, right?
Yes.
You give me average and say, look, If I see the average to be, let's say, 8.5 or 9 plus, then I'll say that you're academically excellent.
Sir.
Is that clear?
Yes.
That's precisely what we are looking at. You're getting it? This CGPA is a better predictor of your entire performance. Are you getting it?
Yes. Yes.
That's all it is. Okay. Are you okay? Is that fine?
Sir, but why do we calculate expectation then?
See, in case of random experiment, you can see this, whatever that I'm going to look at you. See, this is a sample that I told you now, sample salary. 30 people ka salary, right? But if you want to look
Yes.
at what is the population salary, I won't be able to get it at all, right?
Yes.
That's exactly where this works. Okay.
Okay, sir. Okay. Thank you. Thank you. Sir.
Thank you. Thanks, Professor, for the insights. Thank you, Srinivas Rao. I hope it was good. How can I start pitching this, pitch into this research area? Is there a PhD program from IISc for working? I think you have a lot of this. You probably have to individually get into touch with the professors and you'll get it. I may not be able to give you more insights. You can check on the IISc website itself. Okay. Is there a course in IISc Bangalore where we can do MTech and PhD together, like a dual course? There's nothing like that. You have to either join for a direct PhD or you do an MTech and then a PhD. Since the exam is just a month away, how should we prepare for it? Don't worry, Yash, Ranjan. You do exams well if you've done your assignments well. Is there anything we should practice in addition to assignments and notes? Solve some problems along the assignment lines and then check. What is the title of the book that just suggested? It is by Anil Anarthaswamy. The book is titled How Machines Learn. Could you give some numerical problem exercises on each topic or references from where these exercises can be found? The one done on the board now. See, I would suggest you take any of these multivariate calculus textbooks. You will be able to see online. You have all this textbooks in OpenStax and other things you can check. You'll get a lot of problems you can work out. Worst case, nothing works. I would suggest you to look at universities where they put their assignments up along with the solutions and question papers. Practice them. You will really love them. You will know that, okay, these are also the type of questions that can be asked. It's a humble request to please share or refer some resources for practice so that we can prepare for the coming examinations in a better way and be able to score better. Mukul, I'm 100% sure you'll all do well. Just don't worry about it. I will not be able to tell one source where you can work out. I would suggest, okay, you take any of the textbooks, start solving problems. Just don't worry about this. If you know the concepts, I'm 100% sure your answers will be correct. Just don't worry. Any textbook for any of these topics, you take any random textbook on linear algebra or probability, or probably on optimization, and then work, you'll be able to solve. Don't worry at all. What is the meaning of the statement inside some? This is a question. Aman, could you, Aditya, note down this question. In this course, at the end of each math topic, we can kind of infer different ML techniques like PCA, least squares, and almost having similar formula for concept defining. Is my understanding correct here? See, that is exactly what we wanted to do. See, in some cases where you may find really a very apt technical term to be given for something simple which we do, but that something simple is exactly what you must know so that you are able to learn any advanced concepts from this, and that's precisely what the focus of this entire course. I don't think we have we have diluted the course in any way, but then we have put it in all possible what would I call in as much simple term as possible, intuitive as possible, conceptual as possible, so that you are able to take it forward to, you know, the topics in ML and things. Okay. Aditya, did I miss any questions from the document in which you are actually putting the? Oh, there are so many questions here. NPTEL team, can we just go for another half an hour if it's okay? Another half an hour?
Yes, sir.
Yeah, because there are about 26 questions which I'm still to answer, which Aditya is noting down and putting it here. Please explain me two things again, if possible, with an example of a linear combination of matrix A that represents the transformation T. What is the rank of the matrix and what is the column space of the matrix? How or why is it so useful? See, first thing, when you say a linear transformation. And what is the matrix that represents this linear transformation? Okay, now I have to do it on the screen. Can you see my screen? I guess you can see my screen, right? Okay, great.
Yes, sir.
Yeah, so great. So what I'll do is, let us say I have a linear transformation which works on, or which operates on, let's say, two-dimensional vector space, such that
Sir, sorry to interrupt, but these are from the first live session and these are answered, sir.
already answered, is it? Last time, is it?
Yeah.
Then
Yeah. It's on the top of the page.
Oh boy, I thought you scared me off.
No, sir.
Okay, where oh, that means we still have another. So all the shaded questions I've answered, no?
Yes, sir. Yes.
There's one question which is there. I think I've answered everything then.
Yes, sir.
Yeah. Okay, I think I thought it's like, reading the same slides again. Okay, I think I'm sorry for this. I got a bit. I was wondering if they had put all the things. Include the naive Bayes also. I will explain that. I'll put that in the forum. Just don't worry. Is that clear? Please don't worry. I will put all these things in the forum. Okay. Any other questions or comments that you have as such about the course, where you find that we could have done better, or where you find that it was total disaster? In fact, I saw one of those comments for discrete random variable, which was like saying, I think the professor should learn and come or something. I don't know what mistake I've made, or at least this person should have been able to tell me what was wrong. It's okay. So do you guys have any feedback or any comments as far as the course is concerned, course delivery is concerned, contents, and all those things?
Sir, this is Kiran. Actually, I had a doubt that I have registered to appear for the exam in India, but due to some plans, I'm currently in London,
Okay.
but can I appear here? Is that fine? Like, at that time, I couldn't register for the both places.
I don't know. NPTEL team, you may have to clarify this question. Can they have a change of examination venue? That is something which they will answer. Okay.
Okay, sir.
Yeah.
Like, should I email them? Is that fine?
Yeah. You please email them. I think they'll be able to do this. Okay.
Okay, sir. Okay, sir. Thanks, sir.
Yeah.
Sir, one request.
Yes.
Some other course also, they put something called practice assignments. Means that will not be considered for evaluation, but for practice, they will be posted similar questions. So
Okay.
if that also is posted for every week or whatever assignment, along with the assignment, that would also help. Thing that may not.
You want us to do for this course, or you want us to do for the next course? Next course probably, or next iteration, I'll be able to do.
Yeah, as you wish. According to your convenience, if you do for this course, it is all the better. But
Okay.
if you even do for the next course also, future students will get benefited.
Yeah, I will try my level best to do for this course. Okay.
Yeah.
Let me try my best. Okay.
Kind of you.
Sure. Mukul has posted a question. Let V be the vector space, be a plane passing through the origin R3. Then the dimension of V is 2. A plane has a dimension, it's a two-dimensional space. XY plane, you say it's a two-dimensional space, right? It's a two-dimensional geometry. So the answer is it has dimension 2. Prakhar, don't feel shy to ask question and all, okay? The questions which other guys are asking feel a little intellectual. You can see, why would you want to look at somebody else and feel that you're asking a very low-level question? Absolutely not. According to us, our questions are important and have to be answered, okay? Please do this. Don't do this. It's not going to help you at all, okay?
Okay, sir. Thank you for the course.
Thanks a lot. Mock test for practicing the entire course. Come on, your mock test has the assignments that you've written, right? Let me see. Yeah, there's somebody who has raised the hand. Who is that?
Hello, sir.
I hope you got the answer. right?
No, sir.
You didn't get the answer, Mukul.
Yes, sir.
I gave you the answer, no? See, plane is a two-dimensional geometry, right? It says very clearly a plane through the origin in R3. Plane through the origin will be a two-dimensional subspace. That's it. The answer is 2. Is that okay? Mukul, we have done this in the class, Mukul. Can you please check that? If you are still finding it difficult, put it on the forum. I will reply to you. I think Mukul is not answering. Why can't it be a vector space if it's dimension 2? The single vector, which is the 0 vector, is a 0-dimensional vector space. We proved that it is happening. Any line passing through the origin is a 1-dimensional vector subspace. We have done that. In R3, I can have 2 3-component vectors which can see. You look at your floor, man. You look at the room that you are in. The floor is a plane, one side of the wall is a plane, and another wall is a plane, right? A plane is basically a vector space. A plane, if it passes through the origin, is a vector space, right? And a plane will have dimension 2 because you just need 2 linearly independent vectors to span the entire stuff. So it's a 2-dimensional subspace. Okay. Mukul, are you okay with this?
So does the origin itself form a vector space? Origin
Of course, origin itself is a vector space, no?
Yes.
0-dimensional vector space. We told that, no? Any vector space which contains the 0 vector is a vector space. And that vector contains only the 0 vector. Anything that you try to do on the 0 vector will be the 0 vector itself. So it's a vector space. Yeah.
Great, sir.
Yeah. Mukul, any question?
Hello, sir. Can you hear
Yes,
me?
Mukul. I can hear you, Mukul. Were you able to follow what I said?
Sir, I am Keval.
Keval. Okay, tell me, Keval.
Sir, my question was on Lagrange multiplier.
It is noted. It is noted. I'll post it in the forum. Okay. Don't worry about that.
Okay, sir, I want to explain like you misunderstand my questions.
Okay, go ahead. Aditya, can you please note down what he says?
So, sir, in one like Lagrange multiplier lecture, you mentioned little like a misunderstanding there. Like in the example number 2, the answer is 1/3. You mention it as a maxima, but I checked it with Hessian matrix, and it's a positive definite. So I think it's a minima, no?
I told you, no, I will check that. The point is, these are some examples which, hello. See, most of the examples that I had done in the entire lecture were made up there in the class when I teach. So I would have made mistakes. Okay. If it's the other way around, I will change it to, I'll patch it up in the video. Don't worry. Is that okay?
Okay, sir. So my question was like, if we have only single values of variables and it gives us the minima of function, then how can we find out the maxima of function?
We don't know single value of the variable. I don't really get that single value of the variable. I am not able to get that.
Like with a Lagrange multiplier, we get the x, y, z, the variable values, which are only like single values. There are no multiple values of.
So what you do is you put those values in your second derivative. Is that clear? Or the Hessian, whatever that is, you put that. Check out what is the number you get. You start putting different values of x and y and check what you get. This will be the minima. If it is a minima, this will be the maxima if it is a maxima. Is that clear?
Yeah, sir. Like when we are putting in the function and we got the value, if it's a minima, then how can we find out the maxima then?
If there is see, at that point where you have calculated, it would be a minima. Is that correct? For example, how do I put it? Okay, I'll send the next with an explanation like how a single function has both minima and maxima at 2 different points. I'll send that example in the forum. Is that okay?
Okay, no
Is
problem.
it? Yeah, I'll do that. Yeah.
Thank you, sir.
Okay. Direction of steepest ascent. At that point is the okay. I think I have to check this answer. I'll check this. Okay. Prakhar, I'll check this answer. It could be a mistake here. The option could have.
Okay, sir. Okay, sir.
I will check this. Okay.
Okay.
I'll check this out. Thank you, Prakhar. Okay, so there's somebody else who's raised hand. Vivek.
Hello,
Hello,
sir.
Vivek. Yeah, Vivek.
Hi. Yeah,
Hi.
so all the lectures were very informative, sir. Thank you. Thanks for your lecture. Yeah, so I had a question and it's in continuation of that. So let's say we are given a problem and we are thinking of solving it.
1 minute, just 1 minute.
Yeah.
Yes, Vivek, please go ahead.
Yeah, so this is in continuation of a question I asked. So we did like at the end of each of the topics, it's almost the same concept through which we are solving the ML techniques, right? So, but then like given a problem, what I mean, like which of the mathematical topics that we can choose to solve a given problem? It depends on the context of the problem, or how it is like.
It does depend on the context of the problem. It also depends on like what is the data presenting to you.
Okay, can you give an example?
1 minute. We also have Ashok Rao sir here. So thanks for joining. I think he left probably. Yeah. See, the simple thing is just look at the data in the first place. Is the data giving you any insights at all about itself in the first place, right? Sir, Ashok sir. You have muted, sir. Thanks for joining, sir.
Yeah, I unmuted. Yeah. Okay.
Oh, okay, great. No, there's a very interesting question that has come. Vivek, can you put that question, Vivek?
Yeah, sure. So, hello, sir. Hello, Ashok.
Hello.
Yeah. So the lectures were very, very informative. Thanks for all the efforts.
Thank you
for putting them out. Yeah. So I had a question. Like at the end of like we did like learn about each mathematical topic like linear algebra, probability, and differential calculus, right? Yeah. And we kind of infer like like for the different ML techniques, like at the end of each of them, we also learned about the ML techniques and how to solve them using each one of the topics. And both like almost all of them have similar concept behind it in solving it. So in that sense, we are given a problem to solve. What kind of mathematical topic to pick to actually solve that particular problem? Does it depend on the context of the data that is given to us, or how? Like if you give an example for that, it will be helpful.
There is no straight answer to that, in the sense that it just depends on what I would say prior experience. You have some standard methods, but understanding the data is very important. Data will give you very good insight as to what kind of techniques is likely to work better than others, whether it is the Bayesian methods or the linear algebra methods. So context comes from domain. So you definitely need familiarity with the domain. And that's why we keep saying that what technique you use to solve a problem more or less depends on the kind of experience you have had, which means you have to equip yourself trying to solve different problems with different methods so that you get a feel for what is likely to work best. All will work. Some will work better than others. And eventually, majority, I do know, they actually end up using solutions from fusion methods. So you actually fuse partial answers from different schemes and work out. It's like taking an opinion from a panel of experts.
Oh, I see. Okay. So generally, like what, like in my industry, like we deal mostly with time series data. So in that, in the context of time series data, what kind of techniques is like widely used?
Reinforcement methods work best because time series data you get continuously streamed, and the next update should actually improve your current answers.
Yeah.
So recurrent reinforcement learning works best.
Okay. Thank you, sir. Thanks.
Thank you.
Sir, in fraud detection, what type of algorithms do you most suit to fraud detection? Say in a bank, you want to detect a fraud.
Yeah. So basically, fraud detection is hierarchical. I mean, you can't actually detect fraud unless it's very obvious in one go. So you need, that's probably the reason why there are multiple checks for any financial transaction. So you must deploy certain hierarchical methods, and only when it passes through 3-4 of them, then you can understand it's not a fraud. That's the only way. And mostly it is signatures. It could be the way they log in, their keystroke patterns, so many things. I have not worked on, because we have not got access to the domain. So I'm not so familiar with what they actually do, but I'm quite aware that it's a hierarchical process.
Oh, okay, sir.
Bayesian nets are used, definitely.
Bayesian.
Bayesian methods.
Okay.
Because those are heavily conditional type of issues. That is done. Then sheer statistics, the number of attempts and some signature patterns of the IP and so many things. I'm really not very conversant with that.
And what type of problems we can solve using machine learning techniques? I mean, in society that we face today on a broad scale. I mean, what are the classification of problems that can be solved effectively? Or
one problem that should not be taken seriously is healthcare, because it has failed very badly in reasoning and explanation.
Okay.
Which is something the doctor gives.
Okay.
Machine learning is very good for predictive type of things.
Okay.
Almost 90% of all machine learning techniques are used in the predictive mode, where you supply past data, develop a model, refine it, and then use it to predict the outcomes for subsequent data. Prediction works very well in machine learning. Reasoning is very bad. Explanation is terrible.
Okay.
I mean, those are research areas, definitely. But non-human domains like finance and other things, then definitely when it's just data, it does definitely better than prediction. So some analytics is very popular and gaining lot of traction now.
Well, okay, sir. Another question is, in engineering, say nuclear power plants or other things to improve productivity or to reduce or to improve the performance of the station output. It depends on so many parameters, So, such type of things, how can we use machine learning?
Yeah, they are doing a lot. Online predictive maintenance and anticipation of breakdown and faults. They are doing a lot now in industry. Including motors, generators.
That is called what? Predictive maintenance.
Predictive maintenance.
Okay.
So it frequently happens that they are able to predict a failure of an important machine well before it actually physically fails.
Okay.
They develop a idea called digital twin.
Digital
twin.
Okay.
Digital twin.
I heard about it. Yes.
Yeah, where they accelerate the twin model and update with the
real time they simulate that.
Yeah, and then they know. In fact, now all jet engines, aircraft jet engines need a digital twin compulsory.
Aircraft
jet engines.
Yeah, jet engines. Okay.
So they have been able to prevent failure of jet engines and mishap in the plane well in advance.
Predicting failure. Okay.
So anticipating the failure and taking preemptive measures. This is very common now.
I'll just answer one question which they put for a problem. This whatever that image that Priya had shared, if I'm not wrong, your answer is wrong because it is A plus A transpose. It should have been. It says A plus A inverse. So the answer is 2A transpose is correct if A is symmetric. So that's the answer. So there's one more question. It says, can you explain the scope of the use of A and ML in turbulence modeling?
Yeah, they're doing it actually. They're doing because turbulence has no closed form solution. You don't have a formula for turbulence. So what they do is they collect all patterns of turbulence. They know the consequences of that. So that data is stored and then it is used in prediction and anticipation. It's a lot of turbulence related research is being done like that.
Okay. So there's one more question which says, how can we use PCA and SVD without losing relevant and the case when the features are highly correlated?
Okay. So whatever you do, PCA, SVD, it works very well when the relevant part is in the low frequency portion of the data. So all your relevant features, if they are in the low frequency, SVD, PCA works very well. Otherwise, you will need more and more terms. So it will be very difficult to do SVD and PCA and reconstruct Cleopatra's nose. You can reconstruct Cleopatra, but not her nose as sharp.
Nice.
So it just depends how well you. Another way to go around that is to look at data features based on wavelets, wavelength coefficients as features. There you can actually pick the most relevant that you want and work it out. So typically PCA, SVD all use Fourier basis for your image and audio. But if you can use wavelets and then you can do even better by understanding. Again, that depends how well you have understood your data. In fact, entire machine learning is simple. How well you know your data. That is the data and the context or the domain. If you know it very well, machine learning answers can be very good.
See, knowing means, the degrees of knowing.
Knowing
What does it mean knowing? Just collecting data is not knowing.
Knowing is experience. Knowing is domain knowledge. You have to be in the, you just can't say, I know Python programming well and I do machine learning.
That is only mechanical process.
So it's very important that we spend time in the domain which we are working to understand, get a feel for what is happening, what is likely to happen, and then use machine learning.
So the domain expert have to be.
Yeah, it's very important to be. That's why it's very important.
Yes.
Okay, so if there are no questions, I think we will wind up. We have already are close to an hour and a half, maybe. So, are there any more questions? There's one which is there. Sir, if the data is already available, why it is succeeding in domains like business but not in domains like healthcare?
See, healthcare needs lot of explanation and reasoning. Human body, life-related issues are far more complex and subjective, unlike finance. Finance is raw data, whether it is from X company or Y company, it is a stream of data. And it has very little subjective entity in that. So there it will work very well. In fact, finance is one field where machine learning is a growing success. And healthcare is a growing failure.
Okay. So there are no more questions. I think we will say bye, and thanks a lot to all of you for. Okay, why is the level curve orthogonal to gradient? I think I have answered this in the session only. See, level curve is basically what you call where there is no change at all, right? And you are looking for the gradient which is there in the direction of maximum change. So it has to be like 90 degrees. So that's why it's orthogonal to each other. Okay. So I think on that question, we'll wind up this. We thank all the participants and registrants for the course, for making the course very interactive and interesting. I mean, especially the kind of discussions that we have had on the discussion forum, online, and all these live sessions. It was all wonderful. Thanks a lot for all your participation. Again, I thank all the TAs and our NPTEL backend team, and of course, Professor Umanand for giving us the permission to run this course and all. It was really a wonderful a time that we have had. I hope we will keep the steam going. You can post more questions on the forum and we'll be able to do it. Sir, few words for, okay, I think sir will come now. If you have any other feedback or any other comments, you can tell. Otherwise, sir, can you make concluding remarks for these people, sir?
Yeah, see, AI ML is not a holy grail. It does few things well. You must be very clear whether it's doing well and validate it. Just don't be blind about it. It's interesting, but it needs a lot more from your side. More of common sense, more of idea of outliers, exceptions, all that. Then you can understand what the ML gives. Otherwise, it is like all your MATLAB plots. As long as the syntax is correct, there is an output. So even here, as long as you give some data, you will get some answer. It will not say the data is wrong, things are. It will do its best and give an answer. Whether it is what you are looking for, whether it is correct, is something that you need to be a lot more alert about. Learn well, things will change. Job market also is becoming very funny. Don't put all your eggs in one basket. AI ML is not going to solve much of it. Be clear, diversity and multidisciplinary outlook is going to give you better opportunities. All the best. Thank you for spending time with us. It was nice sharing what little I knew with all of you. Thank you.
Thanks a lot. Thanks a lot to everybody. Thanks, sir. Thanks a lot. So my best wishes to all of you. Please don't worry about the exam. Exam should be the last one that you need to worry about. I'm quite sure you'll all do well. Okay. And some of these questions, which I said I'll post the answers in the forum, I will definitely be doing it in the next couple of days. Don't worry. And again, thanks again for joining this course. Wonderful.
It will be the last session, sir, or again live session?
I do not know if there will be any more because the course is over.
Over.
The course is over. Maybe we can meet live, probably for a coffee or something in Bangalore. If people are ready, we'll meet either in Bangalore or Mysore.
That is great, sir.
Yeah, let us know. Coming to Bangalore is not difficult for me. I live in Mysore. So
I'm already there in Bangalore, so we'll all definitely meet. In fact, I had posted in the group also. If we want, we can also have a nice offline discussion. You're most welcome to come. I can host you for some chai or something. Why don't you come? We'll have some nice discussions. And thanks a lot for this wonderful time. We will discuss the time and venue of our coffee meet in the forum. This might not be the better place to do it. Prakhar, you are most welcome, right? And almost everybody who was free can join us. Thanks a lot, guys. Let's wind up.
I'll give you a call tomorrow when I'm in Bangalore around.
Sure, sir. Thank you.
Yeah.
Thank you, sir. Thanks,
Thank you.
Ashok Rao, sir, and both, sir.
Thank you very much. Thank you.
Yeah. So yes, sir. So guys, thanks a lot. If you have any other points that you want to raise or you want to give your comments or anything about this course, give it
actually, like my doubt was related to what next after this course. Like, is there any suggestions, any course you want to like introduce?
You're asking me if we would do any other courses, is it? Like
Yes.
We have not yet decided. If it happens, it will happen for July next year, because we need some time to prepare. There have been some requests also, but let me see if I can put some probability statistics and things together and make a course. Or probably, in fact, Dr. Ashok Rao is, he is the recipient of the best digital signal processing educator award given by Texas Instruments long back. So we are trying to see if we can put a DSP course, and I'm sure, the course that he does would be a roaring success because he gives it in a very, very intuitive manner, which you'll never get anywhere. So we are thinking a lot, but we need to really see which one to go ahead, right? We'll keep you posted, definitely.
Okay, sir.
Yeah.
Thank you.
Thanks a lot, all of you.
Yes, thank you, sir.
Sure. Wonderful time it was. Wonderful time. Okay. And all the best to all of you.